today I'm going to be talking about dividing fractions, and the objective is divide whole numbers by unit fractions and unit fractions by whole numbers. Now, this is a concept that is new in 5th grade. In 4th grade, the students were only responsible for dividing up to 4 digits by 1-digit whole numbers. So in 5th grade, we're introducing the dividing of fractions. And in 5th grade, students will divide whole numbers by unit fractions and unit fractions by whole numbers. For example, we'll have a whole number of 5, and we're going to be dividing that by the fraction of 1/2. In the future, it will look like this. We'll multiply and divide rational numbers fluently. Now, before we begin, there are some non-negotiable strategies that you need to be aware of when working, when working with the students and planning for your lessons. These are just a few of the non-negotiable strategies, and they are the think, process time. Make sure that you're giving students time to answer the questions. Make sure that you're giving them structured talk time. With structured talk time, you want to give students about 1 or 2 minutes just to discuss a problem and so that they're able to solve it together. Remember to also do think out louds. So go over an example with students modeling your thought process out loud to solve the problem. Randomization, and for this you can use various strategies such as popsicle sticks. You can use stickers on the desk. You can use student characteristics. You can even use Class Dojo. Whatever randomization tools that you have in the classroom, make sure that you're using those. And then also practice time. Make sure that you're giving students an opportunity to practice problems after you have done some together as a class. So here's an example of a think out loud. And here we're working with dividing fractions, but here we're dividing fractions using the common denominator. And this is, you need to make sure that when you're teaching students to divide fractions, make sure that you're teaching them this before you teach KCF. And this is how this works. So when we begin, we have 4 as a whole number, and then we have 2/3 as our fraction. We have to turn that whole number into a fraction. And we turn that whole number into a fraction by putting 1 as a denominator. So now we have 4 ones divided by 2/3. But if you notice here, we have 2 denominators that are completely different. So we have to find the common denominator, and we find the common denominator by using the puffy L. We write our denominators here, and we're going to use our first 5 prime numbers, 2, 3, 5, 7, and 11, so that we can simplify the fraction. And if the fraction is already simplified, all we would do is we would circle the numbers and multiply them, which in the situation, if we try to bring 2 down here and divide 1 by 2, we can't do that because the 2 is too big. So this is already simplified. We just circle it, and we multiply 1 times 3, and that gives us 3. So that's going to be our common denominator. So we've got to set up our problem: 4 ones and 2/3. Our common denominator is 3. So in order to go from 3 to 3, we had to multiply at 3 times 1. So we've got to multiply the 2 times 1 up here to give us 2. Then in order to go from 1 to 3, we had to multiply times 3. So whatever we do to the denominator, we have to do to the numerator. So we've got to multiply the 4 by 3, and that gives us 2. So now our problem, now that we've found our common denominator, our problem is actually going to be 2/3 divided by, 12/3 divided by 2/3. We solve our problem here. We go 12 divided by 2. That is going to give us 6, and 3 divided by 3 is 1. And then we have 6 divided by 1, and that gives us 6. So our answer for this problem is going to be 6. This is the way that you should be showing the students, so that way they understand how the process goes. Now, we also have what we have here when dividing fractions, inverting and multiplying, which we all know as KCF, or keep, change, flip. Okay? So in this situation, this is more, you need to keep in mind that this is more of a trick. So you need to make sure that you're teaching the kids how to find the common denominator before going into teaching them the trick here. And to solve it, now this is, if you notice, this is the same problem as the previous slide. So to solve it using keep, change, flip, this is what the problem would look like. We turn our whole number into a fraction by adding a 1 as a denominator, and our 2/3 stays the same. So now that we have our whole number set up as a fraction, now we can begin, we have it set up as a fraction, we can begin using our keep, change, flip. So the first fraction, we keep it the way it is. We're going to change division to multiplication, and then we're going to flip 2/3, and now it's going to be 3/2. Now we can solve our problem. We go 4 times 3, that gives us 12. 1 times 2 gives us 2. And then we have 12 divided by 2, that gives us 6. And if you notice, we got the same answer. We just have two different ways of working them out. Now we're going to work out an example in order to incorporate the thinking process, having the kids get familiar with the models, and just working it out using the algorithm. Okay, so our problem here, we have 1 divided by half. So what does this mean? Okay, so whenever we have a fraction, most of the time we don't really stop to think about what this fraction means. So when we have a fraction like this is what it means. It means how many halves are in 1. So it's pretty much asking us, what this problem is asking us how many halves. It's asking us how many halves do we have in, 1. Okay? And so we're going to move into the model here. And when we move into our model, you notice that we're starting out with 1 whole first, because what we have up here, we have 1 whole up here. So we're drawing 1 whole. And we know that our whole, we're splitting up our whole into half. So we go ahead and draw underneath it, under the whole, and we're splitting it into a half, showing us that this whole is split up into half. And that gives us what? If you notice, that gives us 2. So now let's move into the algorithm here. And the same way as we did earlier, we have 1 whole, we're dividing that by half. We've got to turn that whole number into a fraction, and we do that by adding 1 as a denominator. And now we have 1 1 divided by half. And now we're going to do our keep. Remember, we keep the first fraction the same. We change division to multiplication, and we flip 1/2, and now we have 2 1s. And we solve. 1 times 2 is 2. 1 times 1 is 1. Remember, when you have a fraction 2 1s, a fraction is the same thing as a division problem. It's pretty much saying 2 divided by 1. And when we divide 2 divided by 1, we get 2. You can check yourself to make sure you did this correctly, because your answer that you got here when you solve the problem should be matching your picture. We got 2 as the answer, and we got 2 for our model. So we know we worked out the problem correctly. Okay? Now I'm going to give you the opportunity to partner up with a partner. I'm going to give you guys a couple of minutes to look at the problem, 1 divided by 1/3. You're going to look at your thinking. You're going to tell me, what does this mean? What does 1 divided by 1/3 mean? Then I'm going to have you draw a model. and then I'm going to have you guys solve the problem. Like I said, I'm going to give you about 2 to 3 minutes to give you some time to think and process the problem, and just time to talk about the problem and how to solve it. You guys can go ahead and begin. Okay, and in the classroom, you would give the students enough time to solve this problem because, we're doing this as a training, and I don't necessarily have students in the classroom. I'm going to go ahead and go through the steps of what I would do. So I would start out with the thinking, and I would begin with asking the students, okay, well, what does this mean? I would pick a popsicle stick and then give the student the opportunity to tell me what this means to them. And of course, I would want the students to tell me what this means. It's how many 1/3 in one whole. Okay, and then I would ask for a volunteer to come and draw the model. And in this case, I may use, okay, well, who has a green smiley face on their desk? I would have the student come up here and, of course, draw our models here. So, of course, since we have one whole, we would start out with one whole. And then the 1/3, to model the 1/3, we would draw another hole underneath it. But this time, we make sure that we're splitting up the hole into 3 parts. And this would be a good time for me to ask after the student draws the model up there. This would be a good time to ask the students if anyone has anything different. And if anyone has anything different, just give them the opportunity to talk and explain what they did differently and, what their picture looks like. And then the last part, I would have another student, come up here, do the algorithm, work out the problem. Again, I would use randomization. This time I may use ClassDojo. And, ClassDojo has a system of where, you just click it's a spinner and whatever name it falls on, that's the student that comes up here. They would come up here and work out the problem. And we would set it up, okay, 1 divided by 1/3. Okay, they would know that the first step would be to make your whole number into a fraction, and we do that by putting 1 as a denominator. Divide that by 1/3. And then we can go through, they can either use the common denominator if they choose to, or they can do the KCF. And most of the time the students will go and use KCF because it's easier for them. So we're going to use that. So we're going to keep the first fraction the same, change our division to multiplication, and flip our fraction. 1 times 3, we get 3, and then 1 times 1 is 1. And 3 divided by 1 is 3. And now just to check ourselves, we're going to check, okay, we got 3 as our answer. Does the model have three parts? It does, so we know that the problem was solved correctly. Okay. And after going over a few practice problems like that with the students, giving them the opportunity to work them out together with a partner, I would proceed on to the practice work. And for this activity, the students will do a matching activity. They will match a fraction to a model and an algorithm. And after they match those 3 things together, they're going to be responsible for writing down what the fraction means in their own words. And they will be using complete sentences. So this pretty much goes off of the problems that they were solving, except this time they're having to write what the fraction means to them, and they're having to do it in complete sentences. And I would usually give them about 20, 25 minutes to do something like this. And after doing some practice work, then that's when I would move into the closing activity. And for this closing activity, I've chosen to do a quick write. It doesn't have to be anything in depth, nothing complicated. So the quick write that I have here for them would be to use complete sentences to explain how to divide a whole number by a fraction, like the problem below. So instead of just working out the problem the way that it looks here, they're responsible for telling me in words how to solve the problem. And I would usually give them about the last, about between 5 and 7 minutes to complete this. This way, if they're able to explain to me the process of how to solve the problem, then I know that they know how to, how to divide the fractions here.